Welcome back to the deep dive. I'd say that we're tackling something really fundamental for anyone working in or hoping to work in the rail industry. It's all about system safety assurance, SSA. And look, this isn't just about shiny new equipment failing. Often it's the organization itself. I think about that terrible Wallen derailment back in 2020. 2 workers lost their lives. Why? Not a broken part, fundamentally, but a breakdown in communication, in process. Critical safety info about a temporary system just didn't get through properly, which, well, it leads to a pretty sharp question for everyone listening, especially if you're starting out. If something like that happened on your project, could you actually stand up and prove your organization did everything reasonably practicable to stop it? Could you show the evidence? Because SSA, that's your mechanism for building that proof.
Exactly. The law is pretty clear on this. Safety isn't just one person's job. It's a shared duty, and you need, well, a structured way to show you're meeting it. SSA is essentially all those planned, systematic steps you take to get adequate confidence. And here's the crucial bit. Demonstrable evidence that safety is baked in, right through the whole asset lifecycle, conception to disposal.
That phrase, demonstrable evidence, that really shifts things, doesn't it? It's not just make it safe, it's prove it safe, potentially in court. That's a different mindset entirely.
It absolutely is. Think of SSA as like the organization's safety nervous system. It forces you to look for hazards methodically. It coordinates how different engineering teams respond, and it makes sure every single control is checked, double-checked, verified before anything goes into service.
Okay, before we get into the how-to, we need to nail down that legal standard you mentioned. Reasonably practicable. You hear SFA, PAIM so far as is reasonably practicable, or sometimes ALARP in other fields. What does that actually mean when you're looking at budgets and project plans?
Right, SFIRP or LR. It's foundational. Look, the law gets that zero risk isn't really achievable, right? But SFIP forces you to weigh the risk reduction you get from a safety measure against, well, the sacrifice needed to implement it. The effort, the time, the money.
Sacrifice.
Yeah.
Meaning cost.
Cost, time, complexity, yeah. If a control could significantly cut a major risk and the cost or difficulty isn't grossly disproportionate to that safety benefit, well, then you simply have to do it. It's not optional.
So let's say a $10 million fix prevents a potential catastrophe, even one that's like super rare, once a century type thing. The company has to spend the $10 million.
In many places, yes, unless they can rigorously, legally demonstrate that cost is just wildly out of proportion to the safety gain. And the key thing for engineers isn't just knowing the rule, it's the documentation. You need that audit trail. Often you'll see things like LR triangles or cost curves. You have to show you're working, quantify the risk reduction versus the cost. You justify why the remaining risk is acceptable. And if you decide not to do something, you better have documented proof showing why it was disproportionate, or maybe even introduce worse risks. That systematic proof, that documentation, that's SSA in action.
Okay, that level of rigor, that documentation burden. It leads us right into our first main section, the mandate. This isn't a nice to have. It's a legal must.
Absolutely non-negotiable. For rail transport operators, RTOs, the duty under laws like the Rail Safety National Law, Section 52, for example, it's non-transferable. You, the RTO, you own the risk legally. Even if you hire a top global firm to design your new signaling or you contract out the track maintenance, you can't delegate that ultimate duty of care. You're still on the hook to ensure the whole system is safe. SFARP.
That's a really big point for younger engineers listening. You might work for a supplier or a contractor, but you need to understand that the operator, your client maybe, they're the ones ultimately holding that legal responsibility.
And it flows down the chain too. Section 53 of the RSNL, for instance, puts similar duties on designers, manufacturers, suppliers. If your company makes, say, signaling relays, you're regulated directly. You have to provide your own SSA evidence showing your product is safe, SFARP, as designed, and that you've clearly stated how it needs to be operated and maintained safely. Now, beyond just staying out of court, there are huge operational reasons to do SSA properly. The big one, risk visibility. Good SSA gives you a structured way to see hazards right across the entire life cycle, from the first sketch on a napkin right through to decommissioning decades later. It stops that tunnel vision where people only focus on, say, the construction phase or the first year of operation.
And when that visibility fails, well, when you get tragedies. The Nana Glenn derailment in 2021 seems like a textbook case of that kind of organizational blind spot.
Nana Glenn is, a really painful example of what happens when old assumptions aren't challenged. A freight train hit washed-out track after major flooding. The investigation found the rail infrastructure manager's safety management system, their SMS, just didn't have robust enough processes for assessing flood risks, especially in the face of, well, more extreme weather patterns. The original design assumptions for drainage may be decades old. They just weren't revalidated against current climate data.
So the safety case, maybe written 50 years ago, was based on rainfall assumptions that just weren't true anymore. If they'd had a proper integrated SSA program running, what would have caught that? Where was the specific SSA failure?
You can trace it back to a couple of things we'll dig into more later. First, a failure in what we call assumption management. The assumption that old rainfall data was good enough, that just lingered unchecked. Second, the hazard review process over the life cycle wasn't strong enough. Proper SSA demands periodic formal reviews. You look at your old safety arguments and you challenge them against new threats like climate change impacts. It would have forced them to ask, hey, are these culverts still adequate before the flood hit?
That makes a lot of sense. Okay, let's clarify roles quickly. When we talk about setting up SSA, you first need to know who's who in the zoo, legally speaking. We've got rolling stock operators, RSOs, and rail infrastructure managers, RIMs.
Yeah, those are the main players, often both accredited as RTOs. RSOs, they run the trains. WIMs, they manage the fixed stuff track, signals, bridges, power. Now, on big, complex projects like a totally new metro line, you might have multiple players. It's crucial, really crucial, to define clearly who's responsible for what right at the start. Who owns the track? Who owns the trains? Who accepts the safety case for the signaling versus the onboard systems? You hammer that out and document it early, usually in the System Safety Assurance Management Plan, or SSA.
Okay, understood the why. Now the how, Section 2. Scoping the SSA program. How does a team actually figure out how much SSA effort is needed? You mentioned the impact assessment.
Exactly. The impact assessment, sometimes called a criticality assessment, it's step one. And it's vital because it stops you, well, wasting resources on low-risk stuff, but also ensures you go deep enough on the high-risk changes, putting in new station lighting. That needs a very different level of SSA compared to rolling out, say, a brand new driverless train system.
Makes sense. So what are the red flags? What kind of things immediately tell you, okay, this project needs the full, comprehensive SSA treatment?
We look for specific triggers, usually around uncertainty and the potential consequences if things go wrong. First, novelty. Is this totally new for your railway? Or maybe using existing tech in a completely new way? Second, technology maturity. Is it proven, off-the-shelf stuff? Or is it cutting edge where maybe the failure modes aren't fully understood yet? Third big one. Interfaces. Lots of connections, complex connections, especially linking new kit to older high-risk systems. That's a classic hotspot. Think, putting a modern software-based train onto signaling from the 1970s. Fourth is just the sheer complexity of the change. More complex means more chances for human error during design or installation. And finally, maybe most obviously, potential consequences. If failure could lead to catastrophe, multiple deaths, major environmental damage, huge operational disruption, then yeah, you're automatically in the high-risk zone. Comprehensive SSA needed.
So if you kick even one of those boxes, like high consequence or high novelty, you're probably heading towards that critical classification. How do you make that official?
You use a criticality matrix. It's basically a simplified risk assessment right at the start. You look at likelihood versus consequence using predefined categories. And the rule is pretty strict. If any potential risk you identify early on lands in the catastrophic or critical consequence boxes on that matrix, then the entire project gets classified as critical.
And when it hits critical, what's the immediate implication? What absolutely has to happen then?
Right. So if it's critical, you're triggering the need for comprehensive SSA. That means really detailed application of safety standards like Senelec. You'll need a full formal safety case document. And almost certainly, you need to bring in an independent safety assessor, an IS. Right away.
Okay, criticality set.
Yeah.
Now, how do you decide exactly which SSA tasks need doing? You just, do everything?
Well, you start with a standard baseline list. Industry bodies, like our SSB here in Australia, often publish guidelines with typical SSA tasks. You take that list, but then the crucial part is tailoring it. You have to explicitly justify and document any standard task you choose not to do. Say you decide a specific type of RAMS analysis isn't needed for this particular widget. Fine, but you must write down why. Why was it unnecessary? Or why was the effort grossly disproportionate to the risk it addressed? That justification, that record of your decision-making, that's prime SFA RP evidence. It shows you thought about it. You didn't just ignore it to save time or money.
Okay, so the impact assessment diagnoses the risk level, sets the stage. Now, Section 3, establishing the structure. building the internal framework to actually do the SSA. What are the essential structural pieces you need inside the organization? You mentioned 4 key elements.
Yeah, 4 things that are really non-negotiable if you want SSA to actually work effectively, meaning safety decisions get made on merit, not just politics or budget pressure. First, direct safety reporting. Your lead safety assurance person, the one ultimately signing off on the safety case, they need a direct, unlocked reporting line straight to the top executive, the project director, maybe the CEO, whoever controls the money and the schedule.
Hold on. Direct safety reporting. That sounds potentially tricky. Couldn't that person, hold the project hostage over minor safety points? Or worse, couldn't their concerns just get overruled by an exec focused only on the deadline?
That's precisely why the direct line is so important. It provides insulation and forces accountability. If the safety manager reports, say, 3 levels down the engineering chain, it's too easy for their concerns to get filtered or watered down by middle managers under pressure. Reporting directly forces that top executive to personally confront the safety issue, hear the unvarnished assessment, and make a formal, documented decision on whether to accept the risk or demand changes, which ties into the second point. Second, executive accountability. One single exec needs to be clearly named as having ultimate accountability. For the asset safety, for the assurance process, for legal compliance. They can delegate tasks, sure, but the legal responsibility, it stops with them. Third, a dedicated requirements team. This group is absolutely vital for configuration management. They own the process of developing, documenting, and managing all the requirements for the asset, including making sure safety requirements coming out of hazard analysis get properly defined, captured, and tracked. And fourth, the assurance team. They manage the overall SSA framework, the governance. They ensure the requirements are being met, the evidence is gathered correctly, the formal reviews happen. They basically quarterback the delivery of the safety case itself.
That structure sounds solid, but it's only as good as the people in those roles, right? SSA isn't just general engineering. It needs specific skills. How do you define competency for the people actually doing the heavy lifting, the analysis?
Right. Competency is huge. It's not just about having an engineering degree. For your SSA practitioners, the folks doing the FMEAs, the HA-ZUPs, they need deep technical understanding and specific tool knowledge. We're looking for people who've actually applied these techniques, not just heard the acronyms. So things like failure modes and effects analysis, FMEA, they need hands-on experience systematically working through potential failures and their impacts. Understanding RAM's reliability, availability, maintainability, safety, how to quantify system performance and safety targets. And crucially, they need to be really familiar with the regulatory landscape and the key standards, like the CNELEC EN 50126, 50128, 50129 family for functional safety. A background in systems engineering is often a big plus because SSA is fundamentally about managing complex systems.
You mentioned FMEA. That's not just filling out a form, is it? It really forces you to trace potential problems right back to design choices. Could you maybe quickly touch on another core concept practitioners need to get, like SILs, safety integrity levels?
Oh, SILs are absolutely fundamental, yes. SILs run from 1, the lowest, up to 4, the highest. They're basically a measure of the risk reduction required from a safety function. How reliable does this protective function need to be? The SEFIL level is determined by how severe the consequence of failure is and maybe how often it could happen. A practitioner needs to know how to allocate SILs properly, using formal methods risk graphs, maybe HAZOPs. For example, if a brake system failing could cause a catastrophic collision, the safety functions controlling those brakes will likely need a high SIL, maybe SIL 3 or SIL 4. That means the design, the hardware, the software all need extremely high levels of redundancy, fault detection, and proof.
So for our audience, the students, the early career folks, how do they actually get that specific competency? What should they look for?
Well, look for roles early on that involve verification and validation, V&V, or configuration management, or test engineering. Getting your hands dirty, proving that a system actually meets its requirements, that's often the best grounding for understanding the whole SSA evidence trail. And organizations, they must back this up. They need a proper, systematic competency management system. Identify all the roles that count as rail safety work, clearly define the skills needed for each, and keep meticulous, auditable records of training, assessments, qualifications.
Okay, so all this, the structure, the competent people, the methods, it all comes together in one key document, doesn't it? The System Safety Assurance Management Plan, the SNMP.
The SMMP, yes.
Yeah.
That's the Project Safety Bible, essentially. It's the documented roadmap, and it has to be a living document. Developed early, agreed upon, and then updated as the project evolves. It's the single source of truth for how safety assurance will be managed and delivered for that specific project. A good SMP has got to cover the scope clearly. Define all the roles and responsibilities, who does what. Specify the standards you're working to, like Senelec, set the high-level safety objectives, and crucially, it details the entire hazard management process, how you'll find hazards initially, how you'll analyze and evaluate risks, how you'll define safety requirements and trace them back to controls and evidence. It also needs to cover how you integrate specialist areas like human factors or RAMs and define exactly what the final safety assurance report, LOSAR, will look like.
Right. The SMP sets the plan. Now we execute it. Section 4. Assurance in action. This is about generating the proof, right? You mentioned 3 levels of assurance, like layers of defense.
Exactly. Layers of defense, creating that robust audit trail. Level 1 is design assurance. This is all the internal stuff the delivery team does. Their own internal quality checks, following their safety management system, doing their engineering verification and validation, internal audits. It's about proving they built the thing right according to the plan. Level 2 is independent review. This is where you get eyes from outside the immediate project team looking at it. Things like independent design checks, maybe an independent professional review by a subject matter expert. And the big one here, especially for critical projects, the independent safety assessor, the ISA. This layer checks if the safety argument itself holds water and meets the standards. And then level 3 is acceptance assurance. This is the final check, usually done by the RTO, the operator, or whoever is formally accepting the asset onto the network. They perform their own due diligence, review all the evidence from levels 1 and 2, and make the final call, often through a formal body like a configuration change board or CCB.
Let's zoom in on the ISA. You said they're usually needed for critical projects. Why is getting them involved early, like concept phase early, so incredibly important? What goes wrong if you wait?
Oh, waiting till the project's nearly finished is probably one of the most common and most costly mistakes you can make. An ISA brought in late, they can only really review the paperwork that's already been produced. And what often happens is they find fundamental flaws. Maybe the initial hazard analysis was weak, or the requirements weren't defined properly, or the chosen SIL level was wrong. Finding that out late means huge rework, massive cost blowouts, terrible delays. But if you appoint the ISA right at the beginning, they can review the foundational stuff, the SMB itself, the preliminary hazard analysis, the SIL allocation while the design is still flexible. They provide assurance progressively at key milestones. It gives the project confidence they're on the right track rather than just confirming failure right at the end.
And that independence is key. How separate do they really need to be?
Genuinely independent, completely separate organizationally from the company that built the system, the supplier, and critically independent from the RTO's project management team too. That separation is vital to shield them from the inevitable schedule and budget pressures that swirl around big projects. Their loyalty has to be to the safety integrity, not the delivery deadline.
What kind of common problems do ISAs typically uncover when they do their assessments?
You see recurring themes. Inadequate hazard identification is a big one. Hazards just completely missed or not described properly in the hazard log. Incomplete documentation, or documents where you can't trace a safety requirement through to its proof, its evidence. That lack of traceability is a killer, and quite often they find the proposed ways to control risks are just weak. Or maybe the project hasn't actually followed the rules properly for the assigned SIL level. Non-compliance with the standards is sadly common.
Okay, so the ISA produces their report, the ITAR. That then goes to the final gatekeeper you mentioned, the Configuration Control Board, the CCB.
Yeah.
Sounds like the ultimate decision-making body.
For complex changes, yes, it effectively is. A CCB is highly recommended. It's usually a formal committee made up of senior subject matter experts, SMEs, from all the key areas: operations, maintenance, safety engineering, maybe finance. Their job is to rigorously assess a proposed change and decide, should this be allowed onto the operational railway? Does it integrate safely with everything else?
Can you walk us through the typical steps, the phases of a CCB process?
Sure. It generally follows 4 phases. First is initiation. The change request comes in, it's formally logged, and you pull out the current as-is configuration baseline documentation. Second, evaluation. This is where the work happens. Each functional area, safety, ops, maintenance, etc., does a detailed impact assessment. How does this change affect us? What are the risks? What are the costs? What needs to happen? Third is disposition. The board meets, they review all the impact assessments, they debate, and they make a formal documented decision. Approve it, reject it, maybe defer it for more information. And that disposition is crucial. If they approve it, the CCB is essentially the body that formally accepts any residual risks based on the evidence presented, including the ISA's findings. Finally, implementation. If approved, the change gets rolled out, verify that it's done correctly, and then the configuration baseline documentation gets updated to reflect the new as-is state. We saw this work really well on big projects like the high-capacity metro trains build in Melbourne. They had ISA engagement right through and a strong CCB process for managing changes.
Okay, this is where we get really practical for the folks listening. We've sketched out the ideal process, but, real projects hit bumps. Section 5, avoiding pitfalls. What are the top, say, 6 common mistakes you see people make that undermine SSA?
Right, the common traps.
So,
Okay, number 1, and it's maybe the most fundamental, treating SFARP as a simple yes-no. Engineers sometimes think SFARP means eliminating all risk, or they just dismiss controls as too expensive without doing the work. They forget the reasonably practicable part requires that proportionality test. The mistake isn't necessarily deciding not to implement a costly control. The mistake is failing to document the systematic analysis, the weighing of risk reduction versus sacrifice. If you can't show why the cost was grossly disproportionate with evidence, your SFARP argument falls apart.
okay, that makes sense. What's pitfall number 2?
Confusing SSA with the General Safety Management System, the SMS. Look, the SMS is your organization's overall safety framework, the day-to-day stuff. SSA is a specific, intensive, evidence-focused process for change for new assets or modifications. They're related, but distinct. When teams blur the lines, they often end up using generic SMS checklists for specific, complex SSA tasks, which leads to, well, shallow analysis and poor evidence trails.
And number 3, you flagged this already, but it bears repeating.
Late ISA engagement. Honestly, I can't stress this enough. Bringing the ISA in when the design is basically done, you're just paying them to find faults when it's too late or too expensive to fix them easily. They must be involved early, reviewing the SMP, the hazard analysis, the SILs, right back in the concept phase. Get them in late, expect budget pain and project delays.
Documentation again. Mistake number 4 sounds critical. It's about the hazard log.
Treating the hazard log as an admin task. So many teams see the hazard log as just paperwork to be filled in at the end. Wrong. It is the absolute core, the central nervous system of your SSA process. It needs to be started right at the beginning, during preliminary hazard ID, and it needs to actively drive design choices. Every hazard identified, every control proposed, every piece of verification evidence needs to be linked back through that log, in real time ideally. Use it actively, and safety gets embedded. Treat it as an afterthought, and you're just documenting failure.
Number 5 seems to link back to that Nanny Glenn example.
Precisely. Inadequate management of assumptions, constraints, and dependencies. This is so dangerous. Every safety argument relies on assumptions, right? Assumptions about how the system will be operated, how often it will be maintained, how competent the staff are, how components will perform. If these assumptions aren't formally written down, captured in the safety assurance report, explicitly agreed to by the operator, and then actively monitored over the asset's life, the whole safety case can just unravel, like the assumption about flood levels did at Nana Glen. You have to manage assumptions like they are risks in themselves.
And the final common pitfall loops back to people.
Underestimating the specific competency needed. Yeah, relying on general engineering smarts isn't enough for complex SSA. Organizations sometimes skimp on setting up proper competency management systems for these roles. SSA demands specific expertise in functional safety standards like CNELEC, in risk analysis techniques like HAZOP and FMEA, in understanding the regulations. You need to invest in training, yes, but also assess and formally track that competence. It's not just nice to have. Proving competence is a core part of the assurance evidence.
That's a great list of warnings. Okay, let's wrap up by looking ahead. What are the big trends shaping SSA right now? How can organizations kind of future-proof their approach?
Well, the biggest shift is definitely digital. We're moving away from endless spreadsheets and paper documents towards digital hazard logs and integrated safety management platforms. These tools enforce workflows, they make requirements traceability almost automatic, and they hugely improve auditability because the evidence is linked right there in the system. Some incorporate things like goal structuring notation, GSN, to make really complex safety arguments easier to visualize and understand. Another huge area is moving from reactive to predictive safety using big data and condition monitoring. We're seeing more and more sensors being fitted to assets monitoring vibration, temperature, electrical currents, you name it. And then using data analytics to actually predict when a component might fail before it becomes a hazard. This allows for much more proactive maintenance, which fundamentally reduces risk.
And testing changes before they go live. How's that evolving?
Digital twins, that's becoming a really powerful tool. Building accurate virtual models of the trains, the track, the signaling. Then you can simulate proposed changes, maybe new software logic or a different operating procedure, and test how it behaves. Identify potential new hazards, validate your controls, all in the virtual world before you touch the physical real way. For SSA, it means you can generate really strong evidence about a change's safety without the risk and cost of physical testing, especially during commissioning. And finally, I'd say SSA is just becoming more holistic. The integration of human factors integration, HFI, is now pretty much standard practice. There's a much deeper recognition that the interface between the human and the system is where many incidents originate. So modern SSA programs demand formal HFI plans, tracking human factors issues, designing systems that aren't just technically safe, but also minimize the potential for human error during operation and maintenance.
It really sounds like this systematic approach, SSA, is the bedrock of a safe, reliable railway. So let's boil it down. What are the absolute key takeaways for you, the listener, the student, the early career engineer, to put into practice?
Okay, takeaway 1, safety is your duty. Really internalize SFARP. Don't ever assume safety is someone else's problem, that legal duty. It sticks with you, even if you delegate the task. 2, learn the language and the tools. Get comfortable with the jargon SAL, CCB, SMP, SAR, ISA. Seek out opportunities to actually use the tools like FEMEA, HAZOP, risk matrices. It lets you engage properly in the safety conversation. 3, always think life cycle and traceability. Safety isn't just a check at the end. It starts at the concept phase. And make sure every requirement, every control, every piece of test evidence can be clearly traced back to the hazard it's addressing. That traceability is gold. And 4, document everything systematically. If you make a decision based on SFARP, show you're working. If you rely on an assumption, get it formally accepted and recorded. Your auditable records, that's your defense, your proof.
And just to recap the core steps for setting up SSA. Start with that thorough impact assessment. Build a clear organizational structure, making sure you have that direct executive safety reporting line. Get the independent safety assessor involved early if it's critical. Develop and maintain a comprehensive, living SMMP. And manage all changes rigorously using something like Configuration Control Board.
Absolutely. And ultimately, all these processes, all these structures, they rely on something deeper. Safety culture. The real success comes from fostering an environment where anyone, truly anyone, feels safe to stick their hand up and say, hang on, I'm worried about this hazard, or I don't think this control will work, or is this assumption still valid, without fear. When safety consistently wins out over schedule or budget pressure in those moments, that's when you know your SSA system is truly working. It protects the company, sure, but more importantly, it protects lives. Every worker, every passenger.
A really powerful point to end on. Thanks so much for taking us through that deep dive today. Really valuable insights. We'll catch you next time.
Thanks for listening to Safe Tracks, the System Safety Assurance podcast. Here, we talk all about how safety assurance keeps our railways running safely, smoothly, and reliably every single day. If you're curious about RAM management, RAM analysis, and how reliability is actually calculated, check out the RAMs Ready podcast playlist on this channel. It's packed with great insights. And hey, don't forget to subscribe and tap the notification bell so you'll know the moment a new episode is out. Until next time, stay safe, stay assured.